もしやコスモでは。
Cosmo makes me free.
Cosmo AP Luxury Sports.
Well, for shits and giggles, before I gutted it for the needles, I powered the donor cluster up, and hey, it works. Searching the internet, apparently these E90 clusters are really popular for things like racing sims and whatnot, so the CAN messages to control it are easy to find. If I wanted to, I could hook that directly up to the Megasquirt and run the gauges. And I could have swapped it into the Cosmo if I wanted, but don't know why I would want to do that. Never taken one of these clusters apart before, but I've taken apart a few clusters in my time, and most of the time the bezel kind of just snaps off once you remove a few retaining screws. I don't want to have to destroy the whole thing, so I just want the needles. Might be some good stuff in here. Well, that was easy enough. Well, for absolutely no good reason. I just want to see what's behind here, but for the life of me, I can't figure out how this detaches. It wants to. Aha! Bottom side. Sometimes you get lucky and they just pop right off. Nice. Yes, I'm kind of being unnecessarily gentle for a part that I just want needles from. There's no point just wrecking stuff for the purpose of wrecking it. But who knows, I might want to use these nice gauge faces sometime later. Please fit, please fit, please fit, please fit. Oh, it fits. And that's what... Nah, too easy. That's what he said. Well, these needles have a cool little light pipe that lights the needle from below. And that's pretty cool, but I did not provide any type of mechanism to pipe light into the gauge from my motor mounts nor my backlight boards. So, I'm kind of hoping that the translucent face of the gauge is going to send enough light into this little crevice that the light pipe picks it up and lights the needle faintly. The other option is, if that doesn't work, I hate to say it, but I can go back and disassemble the cluster and route a small channel in the back of the gauge, connect a piece of fiber optic to one of these backlight LEDs, and then pipe it through so that the light pipe can catch it. Length is pretty good, almost like I measured. The coolant and fuel needle is maybe 3 millimeters too long, easy to trim. Well, I think all the hard work is done. So that must finally mean it's time to assemble the sucker. I'm going to start by mounting the controllers in a case, and I actually found these nice flanged cases at the local electronics store. Perfect size. I mean, quite literally perfect. There's about a millimeter of clearance on each end, which saved me the pain in the ass of printing one. little bit of countersink for the screw head. I drilled the holes just big enough so that these tiny M2 screws will cut their own threads. And now I'll just run some nuts down so they're a little bit above this flange here. And just a little bit of Loctite on there so that they won't go anywhere. Let's just do that the width of one flathead screwdriver blade. That works. Toss some washers on there. Slip it on the board. Another set of washers. Yeah, they're pretty close to that resistor. Oh, when I said zero clearance, I meant almost zero clearance. And there we go. Awesome. Now obviously I'll have to drill some holes for some wires, but I'll do that once I start wiring the cluster. Just before final assembly, I want to make sure that everything inside this housing is clean, because the last thing I want are little bits of dust ending up behind my gauge face bezels. So just a quick scrub with some soap and water. And I will also do this to things like the gauge faces and the plastic bezels themselves. I have to assemble this thing from the bottom up. So that starts with the gauge backlights. And these should just go in place with some self-tappers. They just get snugged. They don't need to be cranked down. The boards can flex a little bit to take up the shape of the gauge face. There we go. And I located these connectors so that there's a hope of me getting to them without having to take the boards out of the cluster. And the turn signal board. And this sucker definitely needs to bend a little bit to go in place. To make sure these bolts lay flat enough in these little recesses, I had to grind the heads off. And that means I get to sit here for the next 10 minutes twisting them in with needle nose pliers. I don't need these threads, right? And now tiny nuts. Hopefully I didn't do too much damage to those threads. Now these are just going to be barely snugged down, so a touch of blue Loctite. And the aforementioned snugging. Just using the socket as a driver without any handle prevents me from over-torquing it. Remember way back, all these shims, that's enough Loctite by the way. Remember that all these shims were added to these posts because there used to be a circuit board that went between the white plastic piece and the retaining thing here. So the shims take up the space of that previous circuit board. Don't have to be stupid tight, but need to be reasonably snug. And I swapped out the nice brass screws for some plain but longer steel screws. And of course a little bit of Loctite first. Give it a snug. And a snug. I should have just enough clearance to get the connector in there. And the tack is probably going to have to come out one more time so I can make the cable. So no Loctite on these. It's been so long, I'm actually trying to remember how all this stuff goes together. I guess I could just review the video. But let's see, I know that has to slide in first. Oh, stupid magnetic pliers. Okay. These are actually the little plastic bushings from the tack. They fit perfectly on the slightly oversized holes in the board. A little bit of Loctite, of course. Actually got it. And just snug it down with some pliers. Again, none of this stuff has to be super tight. Loctite will keep it in place. And really, these nuts are just to prevent these bolts from eventually backing out. Okay, just have to make sure this is centered up as well as it can be. Seems about right to me. And reasonably straight. Now I can start assembling the screens. Oh shit. We have a problem. Well, it looks as though I made a miscalculation when I designed the board for the motor, because the pins for the connector stick up and prevent the screen from lying flat. Before I pull this whole damn thing apart and take the board off, I wonder if I can just move these pins down a little bit. Apparently I can move them down, that's for sure. Nope, unfortunately that doesn't make enough clearance because there's a regulator and some other parts right where these pins need to sit. So this whole damn thing has to come apart and this board has to come off. Well, I guess I can use this for something else. Thankfully, I have loads of these motors. I wanted to avoid this because, well, to be honest, it's kind of a pain to work with dangly wires. But the quickest, easiest solution that means I don't have to print up a two-sided board or wait for one to come back from China for 6 months is to just add some wires to the terminals and then just put a connector on the other end of the wires which plugs into the board. I mean, not the end of the world. And some aluminum tape to secure the wires. Well, the way I figure about the aluminum tape is if it's good enough for the OEMs, it's good enough for me. This stuff is widely used to secure wires and other bits. Now, because there's a little bit of adjustment caused by the clearance here, I'm just going to dry fit these together, then get everything adjusted, and at that point put on the Loctite. Snug this down, snug this one down. Okay, now I can loosen one. Oh, too much Loctite. Give it a tighten. Check the screen again. Yeah, looks pretty good to me. And tighten down the other side the same way. be an absolute pain in the ass to work with. I think once I put the Loctite on these, it's not worth putting a washer on because that just looks like unending frustration. Put a washer on that looks like 30 minutes and a headache. Just getting the nut on is going to be kind of creative. Nope, went right on. Slightly snug that up. Keep it really loose for now before I get the other one on. Okay. Push this in place, and then I can snug these up. Not stupid tight, just finger tight. Well, the next screen gets installed in its own little carrier. And it's the same as the last one. Tiny screws held on by tiny nuts. Going to do them diagonally, and then I will tighten them all down. Just going to make sure that's basically centered, and it looks like it is. Give these a snug. Then I just need to do two more like that. I didn't put any Loctite on these because I have a feeling I'm going to have to remove this module in order to plug in the wiring harness. Now the module can go into the cluster housing. Yes, I'm that excited. This has been a long time coming. That's what she said. Well, glad that fits. Well, the last module are the fuel and temp gauges, and since I replaced everything, I know it all fits, so it can just go together. I actually spoke to a Loctite representative many years ago at an auto show. And he said that the one thing that everybody does with Loctite wrong is they use too much. All you have to do is just wet one side of the thread. Just do diagonal corners again. Center this up and then snug them down. The fuel and temp gauge has this cutout under which I positioned an LED so that it can display a warning or something. Mazda used a red plastic diffuser that was stuck to this apparatus, lighted by an enormous light bulb to achieve the same effect. I don't want to use red because my LEDs can display any color. Since I need to make a new piece, fluorescent light diffusers are my first choice, but actually they're disappointingly transparent at close ranges. So I spent 25 minutes looking around the shop for a suitable piece of translucent white plastic. Finally found one. This old Wendy's cup. It's perfectly translucent, and as far as I can tell, it's made of some type of PVC. This cup has been sitting around my shop for years. I got it when I accidentally ordered a combo and said large instead of small, and I kind of couldn't believe my eyes that I received 1.5 liters of Coke in a plastic cup. Seems kind of irresponsible and fattening. No one will ever know. The cuts don't have to be extremely precise because this fits behind a flange on the gauge face, so I'm just using this piece to guess at my width. It's close enough. And we'll score it, cut it. Exactly 3 centimeters. Perfect. I'm using an isocyanate glue. It's really thick. It's kind of a pain in the ass to spread. There we go. As with all isocyanate glues, less is more. Just pop that in place. Then use this Mazda light pipe thingy as a mandrel. Just push her in place. Isocyanates cure with moisture, so it often helps to breathe on it. Nice! Screws aren't long enough. I think I can just drill a bit, make some clearance. Bit of tape to mark my depth. Then just drilled a simple countersink. Perfect. Just going to get 2 diagonals in place, and then I will Loctite the next 2. And these ones will get a little bit of Loctite, and then I'll go back and do the other ones. Assembled. Sweet. With the display fasteners Loctited, it can now get mounted into the cluster. Well, okie dokie, that's assembled. 2 more brackets to make. Need to mount the controllers about here and about here-ish, because that's the only space I have inside the dash. Okay, I'm just going to put about 1 inch of flange on either side of this bracket. So mark off 1 inch and make a line. That'll do. Mark off the bolt holes. Mark this edge, mark this edge. Got a little mark right here. Add 1 inch to this side. Mark the bottom. Another line to show the end of the case flanges. And let's just round that off right here. Another line just to show me where the pedestal for the case flange will end. Make sure to mark that so it goes away. Mark this so it goes away. Oh, this is going to take a while to cut. "20 minutes later. Now I'll just drill all 4 mounting holes. I'm drilling them out to about 3.5 millimeters so that I can tap them for M4. Now I'm going to mill all of the black areas down to about 3 millimeters. Maybe I should have just folded a piece of sheet metal or something. Now, just tap each one of these holes out to M4. A little bit of lube in the hole first. Now we start twisting. Well, that should work, and I think I'll just make the bracket the exact same way I did the Nextion screen bracket. So mark that about here to give it some extra length. Got to just open this up a little bit. Okay, about 3 1/4, give or take. And this doesn't have to be absolute 100% perfect because I will have to grind it a little bit. And mark the holes. Now this bracket is going to be very similar to the bracket that I did for the Nextion screen down below, so just need to mark it to cut relatively flush with the cluster housing. I'll just line this up in place, making sure that it's reasonably straight. Then scribe contours of the bracket. Now transfer the contour to the other side of the bracket. Back to the bandsaw. Now to make a few very careful tack welds. Excellent. No damage to the plastic. Hopefully this arrangement prevents any excessive warping. Well, all cooled down and still fits. Bonus. Now, just to mark the mounting hole. One there. Oh, and I have to also mark this hole so I can make some clearance for the bolt. Alright, now let's get it back together. The bracket and the gauge share the same mounting bolt, then the secondary gauge mounting bolt just goes right through the clearance hole. Just have to make a little bit of clearance. Oh, gonna have to get some bolts with different heads on them. Awesome! She's mounted. Now I just have to make a second one exactly like this one to go right there and hold the second control box, but that'll happen off camera. Exactly the same work. Now it looks like I'm pretty good for the second bracket because there's these two screw holes already, about 12.8 centimeters apart. Pretty well centered by eye. Just a set of the stock self-tappers that I removed from this cluster about 2 years ago. Just making some clearance holes for the tack movement bolt. Well, that seems to fit just fine. Needs a slight amount of flex as the back of this cluster isn't quite flat. So what I'll probably do is stick some washers under there. And the tack still fits. Yay! Excellent. Fits. Well, now it's time to start wiring. And I'm going to start with wiring the LEDs because, well, it's fairly straightforward. The wires I'm using are the twisted pairs from Cat5e network cables. Mainly because it's high quality wire and I have lots of it. Throughout this project, I've been using Molex micro latch connectors. Kind of a two-stage crimp. You crimp the copper and then you crimp a small clamp over the jacket. Then once they are all crimped, they can just be pushed into the connector body, obviously making sure to put them in the right spot. Although it is fairly easy to remove and reposition these connectors in case you make a mistake. Always want to leave just a little bit of extra cable length. And I have to cut the power lines because, of course, the power feed has to daisy chain to the next panel of LEDs. There's 3 total LED panels being driven off of this controller, so the power wire has to split 3 times. Only thing about using the Cat5e twisted pairs is you got to solder it quickly. The jacket wasn't designed for soldering temps. A little bit of flux remover. And shrink the heat shrink with the hot air gun. Now on the panel side of this connector, the order of the wires is 5 volts ground, data in, then the 4th wire, which I've chosen to be brown, is data out to the next panel, as these LEDs are daisy chained one to the other. Always satisfying when it clicks into place. The polarity and phasing of each stepper motor is different, so it's about a 25% chance that I'll get it right the first time when stabbing these connectors. Nice thing is though that it's trivially easy to just pop the pins out and change the order of the wire. So if I find out the motor doesn't rotate, just twitches for example, then I know that I probably have one of the phases backwards and I can just repin the cable. Speedometer stepper motor. The tack stepper motor uses a slightly different connector body, only because that's what fit in the available space, but it uses the same terminals as the other connectors. Now this is just going to be a little bit fun to get connected. There we go. Ah, that wasn't too bad, I guess. God help me if I have to get it out. Working on the wire now for the TFT screen. It's 8 leads. I just want to make sure that I get the length reasonably correct before I cut the wire, because it's a lot easier to remove length than it is to add length. These are a slightly bigger terminal because the connector on the screen size is larger at a 2.5 millimeter pitch than the connector size on the board, which is a 2 millimeter pitch. These big ones are much easier to work with. And that's what she said. Now the nice thing is, I've already made this cable before as a test version, so I already know without thinking what order the pins go in. And the orange pair is last. Get in there. There we are. Sometimes they need a little bit of wiggling before they latch. There we go, nice and strong. Gonna get some tiny cable binding eventually, but for now, just a few bits of electrical tape to keep this thing from going wild while I'm running it. I thought about using ribbon cable. Problem is, ribbon cable is just so damn thin. And of course, off camera, a second cable was made. Exactly the same as the first, for the second LCD screen. That will either be the trip odometer or the odometer. Now just a matter of fishing these cables through, and I did leave a little channel in all the machining, but it is a little bit fiddly to access. So 2 more stepper harnesses needed and 1 LED harness for the fuel and temperature gauges. Now I have to admit that these are kind of the wrong connector body for these sockets. They do go in here with a little bit of forcing, but I'll have to put in an order for the right connector bodies before all this goes in the car permanently and is subject to road vibration. Get in there. I know it's the wrong hole, but get in there. I know it's the wrong hole, but get in there. Seems like that's the title of your sex tape. What the heck am I missing? Oh. Trying to put it in upside down. Also, that's what she said. And the last cable to interface with a part on the cluster is for the screen. That's a Nextion HMI screen, so this cable is a little bit different. All it needs is power and then a serial connection. But I have to remember to swap the TX and the RX between the screen and the processor. Just have to be a little bit careful in how these harnesses route because it's kind of tight in here. Well, I think I went a little bit long on a few of these cables. It's okay, they can get tied up inside the case. Naturally, better to be long than short. And that one's too obvious to make a comment on. And during testing, I already made a cable for the Rotary Encoder, which seems good enough, so that will go here. On the last harness now, this is the sub-harness that connects the cluster to the eventual rest of the harness under the dash. And it just has to carry power and CAN bus to the cluster. Did I mention this is really tedious? I probably have a good 6 to 8 hours just sitting here stripping the last 1/16 of an inch off of these wires and crimping them into terminals. So those 3 are the power supply wires, plus the brown is there to signal the controller that the ignition has been turned on, and then these blue ones are the twisted pair for the CAN bus. Both vehicle sub-harnesses are now done, so we'll just arrange them a little bit. Tape to hold them in place so that I can figure out where I need to cut. So I think roughly And now I just have to join the two sub-harnesses that go to each controller board to the main part of the sub-harness that will meet up with the vehicle harness. All I'm doing here is splicing the wires together, giving it a very quick solder. Probably should have tinned my soldering tip first. And repeating for every wire. And this is going to turn into a tangled mess reasonably quickly. The nice thing is I just kept the colors consistent, so I don't need to think about this at all. Before the heat shrink gets shrunk, some flux remover. I ran out of my spray flux remover. This brush-on stuff is a lot less convenient. I just have the hot air solderer set to 260 degrees. Now that heat shrink I just used was regular old non-adhesive heat shrink. I'll just put a big piece of adhesive lined heat shrink over the top. Looks like that's about a 1/2 inch bundle of wire, and call it about a 1/2 inch tall. So here's the middle right here. It's not quite flat, so it makes it difficult to hold a ruler in place. Not that it really matters, because a millimeter here or there isn't going to matter. I should just be able to pound a 1/2 inch end mill through this. Slowly though. Plastic. Gotta just knock down these sharp edges with a little bit of filing so I don't cut the wires. Don't really need to run grommets. The plastic is as soft as any plastic grommet would be. Perfect. Fits. And nice and tight. Well, of course that's what she said. And also, I made a second one, same as the first, just with the hole a little bit smaller. I'm just about ready to start closing this thing up, putting the gauge faces on. So I just need to make these few connections. I knew this one was going to be a pain in the ass. The little flange on the side is too wide. Oops. There we go. And this one will go in pretty easy. Time to put the needles on, but I've discovered a problem with the fuel and temperature gauge. The motor shafts are way too long and hit the bezel. Putting the needles on will make it even worse because the height of the needle, there's just no way. Of course, the solution is easy, but gross. I have to trim the shaft. Well, this kind of sucks. The only way I think that I'm going to be able to cut these is with the cutting wheel on the Dremel. Very, very carefully. And see, it's not just damaging the face with the wheel. It's also overheating the shaft or applying too much torque to it. I mean, it's not super critical how tall these things are, just as long as there's enough for the needle to engage on. So I'm just guessing at 1 nut's height. I'm not wearing safety glasses because I tried and I can't see it with the glasses on. This is not only how I intend to slip my wrist, but also how I intend to lose a finger. Woohoo! Still rotates, and they sound just as grindy and awful as they did before, which must mean they still work. Now, even with the trimmed shaft, these things sit way too high, so I'm going to have to trim some of the stem here. My only concern, the inner bore of this widens. So I don't know if I cut past here if it'll still grip the motor shaft. Just going to very carefully nip about as much as I can off the bottom of this. It's like acrylic or something, so it has to be very carefully scored. Yeah, there we go. Well, and it's also too long. All the other needles stop where they indicate. This one goes way past. To me, looks like it needs to be 3 millimeters shorter. Oh, here goes. 1, 2, 3 millimeters. Even that out a little bit. Geez, almost like it's meant to fit. It's still too tall. I just checked the fit. I'm hoping I can gain a few more millimeters by taking this black cap off. There's 2 little molded pins in here that I think I can just knock out. Oh, it doesn't matter that the cap's missing because this whole back half of the needle is underneath the bezel. Nope, there we go. Wow, that may have worked. Sigh, it doesn't fit. It's just still too damn high. See, the problem is that the temp and fuel gauges angle in to meet the driver at a better sight line. And I kind of thought this was going to be an issue, but was hoping it wasn't. Except it is an issue. And the only thing I can do is take more height off of the needle. But as I feared, the shaft bore is actually a taper and widens after the first few millimeters. So I can't just slice it off and expect it to still fit on the motor shaft. The only thing I can think of doing is packing this full of epoxy, then jamming it all the way down on the shaft so that I can resize the hole. This is some of the most horrifying smelling stuff I've ever used in my life. It's gonna have to just try to spooge it down the hole here. And I wish I could make a joke about that, but I don't have enough time. Well, with luck, I will be able to get this off of the shaft. And the nice thing is the shaft is clear, so I can see it going down here. The epoxy has had a week to set up, and kind of what I feared has happened. Even though this stuff is not supposed to bond to metal very well, these are well and truly stuck. I'm already at peace with the fact that I'm going to have to destroy these motors to get these out. In fact, I've already broken the zero stop on this motor. Oh, well, that did something. I have the distinct and sinking feeling that I'm screwed. I thought that the oils in my fingers on these shafts would stop the epoxy from adhering, but apparently not. And even though the datasheet says this stuff does not stick to metal, well, it clearly does. So I've already broken the shaft trying to twist it out, and I suspect it's about to break again right at the well, broke again, but I don't think at this point this is recoverable, so might as well try. Maybe I can push it out the other way, or at least shock it loose. Nope. That's it. That's over. I'm gonna have to find a new set of needles. I kinda realized there's a hole in my tack. So, I might as well fill it with another screen. This little OLED screen fits perfectly. And I've just created a little program that fills the entire screen with a horizontal line down the center for alignment. And the wires are pulling on it. Now that it's in place, just tack it in there with a little bit of hot glue. Well, I'm waiting for this glue to cool down. I mean, you're going to ask me, hey, what can I use the screen for? Could be anything. Maybe a boost vacuum graph, or a real-time mileage display, or just a message when I hit red line that says, shift, damn it. Or I could just leave it off. Either way, hole's filled. Now to stick it in permanently, more of this horrifically smelly and apparently stupidly strong plastic epoxy. Now I'm just tacking this again at the corners so that if I ever have to replace this screen in the future, there's at least a hope of removing it. After a week thinking about the needle disaster, I think I have found a simple solution. Found these RX-7 gauge clusters hanging around the shop, so I'm going to steal the needle hubs from them and just glue my BMW needles onto these hubs. Okay, let's try this speedometer. Oh, the fact it came off easy is a good sign. Aha! That looks like the right size hole. Looks like the right size hole? Title of your sex tape. Pulling hubs from the RX-7 speedometer needle and the Cosmo tack needle. Two needle hubs. Fits on there upside down. So it looks like all I need to do is cut a slit to the edge, inner edge of this hole. And I can slot the needle right in. After a little bit of filing, the needle fits right into the slot, and what I'll do is epoxy it together using this block of aluminum and some tape as kind of a jig. Seems to be lining up with the gauge about where it needs to be. Now, just about to do the same thing to the hub I got off the Cosmo tack, but found out the hole doesn't go very far naturally. So I am very, very carefully hand reaming it out with a tiny drill bit. I do not trust power tools. Rather, for this, I don't trust me. And there we go, just went right through. I have this chunk of steel that I use to keep things flat when I'm welding, so I think it'll do as a jig to epoxy these needles on. The trick is that the needle lines up with the bottom of the hub, so as long as everything is held tight together and flat against this steel, should be straight enough. Oh yeah, that'll do it. Really all I need to do is just jam a little epoxy into the crevice here. There you go, that ain't going anywhere. Going to reiterate that these hubs are completely covered in the gauge bezel, so this does not have to look good. It just has to be strong. And I've just learned that this epoxy does not forgive. With the camera off, I also added some epoxy underneath. Yep, that looks like it'll do it. Just remove some of this excess epoxy. And finally, time to stab the needles. So I'm going to spin both these motors down to the bottom position. Put the needle on very lightly, as long as it's a position above bottom. Then slowly, carefully rotate it on the shaft until it's just below the bottom of the measurement. Then push it down. Fuck. Nope, that just broke. Yep, I broke it. See that gap? That means the motor internally, the pins have separated from the coils and it's broken free from the board. That motor's hosed. Even better, the gauge face broke. When the motor let go, my finger must have slammed down on this area, cracking the corner. Thankfully, the cracked portion of the gauge face is actually hidden by the bezel. So I'll be able to use a little bit of super glue and some epoxy around the outside edge and on the back to reinforce it. It'll be a relatively easy repair and will not be visible once it's assembled. However, the motor, well, that's another story. I don't have any spares. And what that means is I'm ordering more from China. Minimum 2-week turnaround, best case. Which means that aside from fixing that cracked bezel, there's really not much I can do further on the instrument cluster for at least 2 weeks. As you can imagine, I am somewhat unhappy. Freaking gel. You know, I don't know why they made this stuff into a gel. Works perfectly fine as a ridiculously thin liquid. It's actually kind of good. Okay. Now that lined up reasonably well. Definitely I'll have to hit it a few more times with some super glue, and then I'm going to reinforce the whole area with some epoxy. It's been 24 hours and super glue has cured, and I'll reinforce the whole area with the epoxy. Okay. Now I'm kind of just going to glom it on here, because obviously I'll have to sand it out later. And I mean, honestly, I don't care how much of a mess it makes, because again, this whole area is invisible. It's under the bezel. Thank you, Mazda, for hiding most of this gauge face. The more you try to smooth this out, the uglier it gets. A 3-week wait, and new motors arrived. I bought spares. Oh, good thing I used blue Loctite. Okay, these are pretty big solder blobs, so I should just be able to solder sucker them up. Yep, that seems to do it. Should pop right out. Oh, there we go. Cool. Okay, and the new motor should just slip into place. Oh, hey, bonus. Probably also doesn't help that there's residue of Flux Remover on here. Or not Flux Remover, conformal coating. A little bit of Flux Remover. And after masking, touch up the conformal coating. That's almost empty. And now to deal with this. Basically just going to shave off all the excess epoxy on the back, then contour this bit a little bit and create clearance around the bolt hole. Pretty good. Had to shave a lot of this epoxy off to make clearance for the cluster housing because I didn't realize how close it was to this gauge face. But it's still plenty strong. Now, re-drill the hole. One size larger. And with that, the repair should be complete. Jesus, I'm going to get all this tape off. There we go. Now, it's not exactly pretty, and the only way I could get away with that is because the gauge bezel covers most of the face. Oh, that's really empty now. Just enough though. Well, and now it just goes back together again. Now, this is basically the last time I'll be able to clean these things before they go back into the cluster. So, just I guess some soapy water and a very gentle wipe down. Good rinse. And gently dry with air. And very carefully snug. No crack, unclench butthole. Now this is where it all went wrong before. What I'm going to do this time is support the bottom of the motor with a shim. Just kind of jam that in there, put some tension on it. And I've also reamed out the hole a little bit with this, the broken motor shaft from the other motor. So now, not quite a hot dog in a hallway, but kind of like a watermelon in a drain pipe. So let's try this again. So the first thing is, I want to stick this on here a little bit, just so that I can be sure the motor is all the way down at its end stop. And I'm going to turn it just below the gauge scale. And now give it a press. And continue till I've decided she's bottomed enough, which is damn close. There. It's about right. Now the same thing on the other side. This one's actually kind of loose. And yeah, they're about even. That's that. I'd say that's damn near even enough. The needles seem to sweep the outer line perfectly, and they both park at about the same spot. Alrighty, we can get back on track, get this bitch assembled. Ah, there we are. Okay. And I'm likely going to have to go back and readjust this because, remember, the driver looks at it at an angle. So there's kind of a parallax effect going on, and like an idiot, I did not note down the original location. So I may have to go back, loosen these things once I'm sitting in the driver's seat and figure out where it actually has to sit. Okay. Oh yeah. I can't be the only one who gets a singular joy in peeling the protective plastic. I have just a little bit of Loctite on these. As years ago, I had these screws vibrate loose and rattle around in the instrument cluster for the remainder of the time I own the car. Just putting a tiny bit of this soapy water into the needle there, just to lubricate it a little bit. Turn the motor all the way to 0, and to insert the speedometer needle. Same strategy as before, put it on a little bit, turn it to make it just below 0, and then push her home. Oh yeah, that's satisfying. That worked quite well. Riding a little higher than I would want, but otherwise fine. The TAC has the integrated OLED screen, so can't forget to plug that in. That would have sucked. And for some reason the TAC screws have these little lock washers on them. None of the other ones do. Again, a tiny amount of Loctite is used. Once again, spin the motor home. And there's just a tiny bit of soapy water on this. Do the same thing, push it on just a little bit, run it just below 0, then push it home. And she's home. Probably should have put my soapy water into a bigger holder. Now, I have a feeling that even though I just cleaned these up and I'm kind of screwing them in, that I'll take them off again and give them a good polish when it's time to finally assemble the car. Now, I haven't quite decided what I'm going to do with this clock yet. I like it. It's like 70s and spacey. I might just repaint the needles to white so they match the new needles. For now though, I'm just going to put her back in the hole to, well, plug the hole. Problem is it doesn't work. I've had it working for a few seconds at a time by powering it up and wiggling the hands, but after that it just stops. So my guess is it's completely crudded up and the movement needs to be either repaired or replaced. It's a Gecko clock, Japanese Electric Clock Corporation, which, I mean, they're really common in Japanese vehicles all the time, so I can just get a new movement, I'm sure. Or I could bite the bullet, take this one apart, clean everything up, and reassemble it, but man, that sounds like a whole video in itself. If you want to see that, let me know, I'll do it. For now though, it's just plugging a hole. Cleaning the last gauge bezel, which is that for the fuel and temperature gauge. For some reason, this is eminently satisfying. You know, I forgot. I'm just going to have to shave a little bit off this gauge face so it clears. Now it fits and clears. Well, that's assembled. The final bit of the mechanical assembly is the rotary encoder. And the nice thing is that I already spent a whole bunch of time lining this thing up. So all I will have to do is put some Loctite on bolts. Somehow get this in here. I don't know who the hell designed this, but I'm kind of an idiot. Okay, and then do the other side. And this side is already lined up by virtue of the other side, so I'll just jam some Loctite in there and tighten it back up, which is a real joy to do. Nice and solid. Now all these next bits have to go in a very specific order. First, the dial shaft. Then I found it was best just to put the nut washer on the shaft. Then the encoder with a bit of Loctite. Then kind of get it on the shaft. Just a little. Kind of a press wedge fit there. Then just try to catch the threads by alternately wiggling everything back and forth. Oh, looks like I got them. Nice. How's that loose? How did all of it get loose? Oh shit, because it broke. Of course it did. Yeah, well, unfortunately, I can only blame this one on myself. It looks like I over-tightened by a lot. Unfortunately, there's really no way of recovering from this. It's completely shattered and it's still coming apart. You know, it's best it happened now because at least I can fix it now versus putting it all back in the car and having it fail after a few miles. Maybe it was the Loctite that destroyed this plastic because it seems reasonably strong otherwise. Either way, it has to get out of the way. I think you can probably see where I'm going with this. Needs to lose about 3 centimeters. This plastic bushing isn't exactly perpendicular to the face. Looks like I'm going to have to cut at an angle. You know, 0.5 centimeter. Okay, crisis averted. Just need to rough up the surface inside a little. And on the outside of this thing, just trying to get all the grease, fingerprints, and loose debris off here. Well, I think that I can fairly confidently say that I have 100% faith in this plastic epoxy at this point. Oh, that smells horrifying. I wish this was smell-o-vision. Basically, my plan is to just pound most of it in here. Oh yeah, I'll definitely have to drill that back out. Line this up as best I can by eye. Looks pretty good actually. Yeah, I'm gonna go out on a limb and I'm gonna say that ain't going anywhere when this stuff dries. Probably 5 times stronger than the original plastic. Okay, well then I'll just set this aside for the necessary curing, and then off camera I'll probably reinforce around the sides a little bit. This is now cured for a week, and it's probably the strongest part of this bezel. So all I have to do is drill up the hole, because I got some epoxy in there. My calibrated eyeball must have been off a little bit the day that I lined that thing up and epoxied it on. So I had to make a little bit of adjustment with the Dremel, but it's running pretty smooth now. This all has to go together in a very specific order to line everything up. So slide the nut and washer over the shaft. The best way to tighten this is to actually spin the whole body. Then the knob has to be threaded on, because that really helps line everything up. The best way to tighten this up is to just use the body of the rotary encoder. Just got to find the sweet spot where it all works. Then snug it up. And finally, this thing should just snap right on, assuming I haven't messed up any clearances with anything I've added. And then the harness for the rotary encoder. Now this could plug into either one of these controllers, but I'll plug it into this one since the length of the cable seems about right. And that's that. I've been waiting 2 years to say this, but mechanically, it's done. Of course, it's not really done, because I have to write all of the software that makes it work, which is honestly going to take months, and it's not something I'm going to do right now. I still have the rest of the car to build, so I have plenty of time to plug away at that software bit by bit. But what I have done is write a really quick demo to move some of the gauges to give you an idea of what it's supposed to look like. As you can see, it's idling well, just under 1,000 RPM. Four-way flashers are on because I'm sitting stationary at 0 miles per hour with a very specific trip mileage. Temperature is good, have lots of fuel, and on the everything screen, I just stuck a picture of a rotor. And thus ends part 51. 51? I think so. Honestly, I kind of lost count. Just a few words on all of this. I know this has been a long one, and I know a lot of electronic stuff was covered, not a car show's usual fare. And I just want to thank everyone for sticking by me during this, because believe me, this right here is a perfect example of scope creep, and I have to admit, I lost my enthusiasm for this cluster at least a year ago. So I'm glad I finished it, and I'm glad I can move on to more cutting and welding.